The human design is miraculous and mysterious, full of individual systems that somehow work together to make us whole. Let's start with the obvious. Our skin's on the outside and the largest of our 9 major organs. Our 10-pound waterproof coat protects us from an invasion of germs and chemicals. It also keeps moisture in. And though our skin is thin, it's complex. In 1 square inch of a hand, the skin sprouts 30 hairs, holds 9 feet of blood vessels, 134 yards of nerves, 9,000 nerve endings, and 700 pain, heat, and pressure sensors. Our skin is wrapped around the muscles and bones that move our bodies and house internal organs. Each of our 206 bones is light and strong. A skeleton made of steel would weigh 5 times as much. Our respiratory system connects the outside with our insides through breathing passages. When we inhale, our lungs allow a quick exchange of carbon dioxide and essential oxygen. The circulatory system carries many of life's essentials through the bloodstream, including oxygen. The heart drives this system. The 4 chambers of this muscle work as 2 separate pumps. One pumps blood to the lungs to pick up oxygen. The other pumps blood through the body to drop oxygen and nutrients off. Nutrients are made available to the body through the digestive system. Whatever we eat moves from our mouths to the stomach and our intestines, where food is broken down into usable substances and absorbed by the blood or stored for later use. We get rid of undigested parts of food, and our excretory system removes excess liquid waste and regulates the levels of salt in our bodies. The brain behind all these systems is 3 pounds of soft tissue, full of 14 billion nerve cells, give or take a few. Thinking produces electrical signals between these nerves and makes a network of connections. Repeated thoughts and actions build stronger connections. The brain communicates with the rest of the body through the spinal cord. From the brain's perspective, our bodies look like this. Hands, tongues, and lips seem huge because these areas of our skin are loaded with nerves and more sensitive than other parts of the body. The work of procreation is carried out by the reproductive system. When an egg and a sperm get together, another variation on the magnificent human design is in the making. While each of our body's systems operates separately, they depend on each other for support. Together, these systems help us function and make us human. This guy owes his strength to the muscles that move his bones. We all do. Take water out of our systems, and the 656 different muscles in our bodies account for half our weight. By contrast, the bones that shape and support our bodies and give our muscles leverage weigh half as much. Our bones are light and strong. Inside, bones are a network of blood vessels and nerves. The centers of some bones are filled with marrow, which produces blood cells. Living bones grow and are replaced as parts are worn away. Calcium and phosphorus, the minerals that build the hard part of bone, gradually dissolve and are carried away by the bloodstream. New bone is built up from minerals supplied by blood vessels, lacing the bone. Our backbones provide protection for the spinal cord, a highway of nerves carrying messages from the brain to the rest of the body, including all our muscles. For every bone that moves, there's at least one set of muscles moving it. Joints, like the knees and elbows, allow our bony parts to work together and amplify the movement of our muscles. Here, the elbow enlarges the motion of the bicep muscle in the upper arm. This range of motion is accomplished with a mere 1-inch contraction of the muscle. Not all well-built bodies need to look like this. Lean, fast response muscles are better for the challenges of balance, agility, and speed. All muscles receive their instructions from the central nervous system. Electrical signals and nerve impulses travel to the spinal cord and then to the individual nerves and muscles. The impulses contract muscles, making them work. Our muscles are fed by oxygen and sugar. They're mounted on a flexible skeleton connected by joints. Taken all together, it's a human work of art in motion. They keep us ticking. 9 glands make up the endocrine system. Most secrete hormones, chemical messengers with specific jobs to do. So far, scientists have identified more than 100 different hormones produced by the endocrine glands. We can look at them in their crystal form. They are beautiful and vital to our lives. Some hormones are produced in the brain, the pancreas, our reproductive organs, and our thyroid. They are carried to every part of the body by the bloodstream, where certain target cells respond to hormonal commands. The pituitary gland in the center of our brains produces hormones to direct our growth and sexual maturity. This little gland with a big job is often referred to as the master gland because its chemistry triggers the work of other glands lower in the body. At the pituitary signal, our reproductive organs produce testosterone and estrogen, seen here in crystal form. They control our sexual development. The little master gland gets us going every morning, too. Each day, the pituitary directs a pair of adrenal glands sitting in our kidneys to produce a dose of cortisol, a wake-up hormone that provides a boost of energy. As cortisol wears off, the adrenal gland produces adrenaline and noradrenaline, hormones controlling fear and anger, to help us greet more stressful challenges of the day. Firefighters may produce a fair amount of adrenaline. In the face of danger, adrenaline gets us to breathe deeper and tense our muscles, priming our bodies for action. All that activity produces wear and tear. We need to replace about 1/2 a pound of muscle and tissue every day. That's a job for the thyroid gland, which helps control the rate at which we process food and burn fat. But it's the pancreas gland, located behind the stomach, that produces hormones to help us regulate our sugar highs and lows. It pours insulin into our blood after a meal, instructing the liver to take excess sugar and store it until we need a boost. In those hungry hours between meals, the pancreas eases up on insulin and increases the flow of glucagon, another hormone that directs the liver to let some of the stored sugar loose into the bloodstream. As night approaches, the production of adrenaline slows and we get sleepy. Overnight, the pituitary gland goes back to work, using growth hormones to help repair the damage of the day, and the chemical clock starts another cycle. Ancient philosophers called our 5 senses our windows of the soul. Modern thinkers may still debate that definition, but we do use sight, hearing, smell, taste, and touch to help comprehend the worlds both inside and outside our bodies. Our eyes, ears, nose, mouth, and skin pick up information with receptors that translate the messages into electrical and chemical impulses sent onto the brain for analysis. Every time we sense, our body receives information while our brain figures it out. When we start off life, our brain requires a flood of sensory experiences in order to hook up properly. We use our 5 senses to form connections in our brain. Neurologist Dr. Ramachandran explains.
Experience early in life has a tremendous influence on the development of the brain, especially the sensory systems in the brain. We could say the basic scaffolding is there at birth, but there is a great deal of refinement and fine-tuning that takes place as a result of early experience.
Over time, our senses help us build billions of connections in our brain, and as a result, things make sense. Because we receive, record, and respond to hundreds of sensory stimuli each minute, we tend to take our senses for granted until something goes wrong. Damage to the area of the brain where color is processed, for example, may not only remove the ability to perceive color, but also erase the memory of it. People suffering from a condition called synesthesia have jumbled senses. A musical note may provoke a vision of color. Food may smell purple. The sight of a certain person may make you feel all prickly. It might seem odd, but this unusual disorder isn't always a burden, according to neurologist and author Oliver Sacks.
I think the commonest form of synesthesia, which several musicians have, is hearing notes as colors. Mozart always referred to D major as a sunny yellow key, B minor seen as a black key, in E major sometimes seen as blue and A as red.
The complete loss of one of our senses may enliven the others. Blind skier Tom Sullivan relies on his sense of touch and the sound of a guide to help him down the mountain. He has a rich sensory experience all his own.
At 12,000 feet, there's the sound of the wind in the aspens. It's one of the most beautiful sounds in the world. There are at least 8 different textures of snow, from corn snow to crunch snow, from powder to ice. Snow has the cleanest smell in the world. It's a non-smell. All that stuff is out there, and it paints a sensory panorama that's so rich, I wouldn't trade it for anything.
The human body is an amazing machine. When its systems work together, the results can be quite extraordinary. Yet we are all born with certain physical limits. Athletes train their bodies to push these limits to the max.
I hear people all the time say, oh, sports are 95% mental and 5% physical. That's bull. I don't believe it. I've never believed it. Forget it. Throw it out the window. Because somebody can be 95% smart and slow, and they're not going to win a race.
Carl Lewis ought to know. Before he became a professional actor, Lewis won 9 gold Olympic medals and a silver in his unparalleled career in track and field. But he also knows that a body built for running and jumping isn't enough. In addition to lung capacity, a volatile nervous system, and fast-twitch muscles necessary to succeed, you need technique and training. Lots of it. Carl Lewis' coach, Tom Tellis, has cut 100 meters down to a science.
The idea of coming out of the blocks is to get the runner in a position to accelerate. Zero. Inertia is zero, and you have to overcome inertia, and that's where you apply the most force against the blocks.
Even the world's fastest human beings can only accelerate for 5 to 8 seconds. After that, the race is to see who can maintain their top speed the longest.
If you accelerate and distribute your energy over 60 to 70 meters, which is where you should, then you only have to have 30 meters to maintain and decelerate. But if you come out of the blocks and reach your maximum velocity or acceleration at 50 meters, then you have 50 meters to maintain and decelerate. And you can't do that.
It's like driving a car. When you get to 4th gear, the engine's racing harder, but when you get to fifth gear, you can still maintain that speed, but it's a more relaxed tempo, and that's kind of the difference we try to do from that 60, 70 meter pace onto the finish line.
Sprinters take 5 strides in a second and cover 2 meters per stride. Each time a foot touches the ground, it carries nearly half a ton of vertical force. 50 paces, 10 seconds.
Then you have the last part, which is about deceleration. In other words, you're slowing down, and it's the athlete who slows down the least is going to be the winner.
Training to be the best can take its toll. Athletes perform the same movements over and over again, and sometimes this repetition leads to problems with muscles, joints, and tissues. These aches and pains depend on the biology of the athlete and how each body responds to stress. The watchful eye of a trainer is a must, because no two bodies are the same.